Okay, hi guys. It is task 2. I'm going to show you this video about worksheet 1. So I'm going to give you, you've been given this big long worksheet. There's 14 on it, and I'll do 3. And then you guys can practice the rest on your own. The answer sheet is attached. So I'm going to do number 2. I'm going to write it out so you guys can see it. Copper plus silver nitrate yields copper to nitrate plus silver. Okay, so that's the question that's on the sheet. Okay, so first thing we're going to do is we're going to look for copper. Well, all we have to do is look at the periodic table and see here that copper is Cu, number 29. So that's pretty easy. Cu plus. So you don't put any charges because when copper is just alone and it's just an element, there's no charge to it. Only when things come into contact with other elements do they get charges. When they're just alone, copper, it doesn't have a charge. So it's just Cu. Boom, easy. Silver nitrate. So down here below, I'm just going to write, this will be where we put our pretty nice answer and scrap. I'm just going to be able to write down here, show you how I got some of this. So this is just scrap space, okay? So silver nitrate. Well, I don't know what that looks like, but I can kind of break it apart. Silver and nitrate, that's what's in it. So I'm going to look at silver. Now, it's in with something, so it's going to have a charge. So I have to look at silver over here, see it right here, number 47, and its charge is a +1. So Ag is a +1. What is nitrate? Well, I have to use my polyatomic sheet or my textbook. That polyatomics are on page 257, and you'd be able to have a look, and you're going to look around for nitrate. Well, I see nitrate right here. It's an NO3 minus 1. NO3 minus 1. So what does silver nitrate look like? Well, I have to crisscross the charges. In this case, they're both 1, so it's easy. AgNO3. That's silver nitrate. So now I get to write it up here. AgNO3. Yields. Now I got to look at this thing, copper 2 nitrate. Well, copper 2, we can look at it, but it told me it was 2. Here's copper. It has a +2 or a minus, or sorry, a +2 or a +1. So they used the top one. They told us copper 2. So I get to go copper 2 and nitrate. Well, I already looked nitrate up. He's an NO3 minus 1. So when I do the crisscross to figure out what this guy looks like, CuNO3 2. Well, that doesn't look right. I moved the 2 down, and the crisscross 1 went down, so there's 1 here, but you don't write it. But the NO3, it looks like I put 32 oxygen, so you have to put the NO3 in brackets. Cu, open the bracket, NO3, close the bracket, then a 2. This copper 2 went down to here. So this is what copper 2 nitrate looks like. So I'm going to write it up here in my pretty spot for my formula. And then I've got plus silver. Well, that's not too hard. I'm going to look here at my periodic table, not my charge side, because it's just an element by itself. Elements by themselves aren't floating around as charged particles. You don't have a little piece of copper in front of you and have it have a charge, so when you touch it, it hurts. That's not what happens. So it's the same thing. All elements, when they're just sitting alone, don't have charges. So silver doesn't have a charge. We just look at it here. Right here, silver's Ag. That's its symbol. We write Ag. So this is the big, long, chemical reaction written out with formulas. So when I look at this, next week I'm going to teach you guys to balance it, but I'm going to show you really quickly, just in case people can follow along. I'll put some blanks to write some numbers in. I'm just going to go back and forth really quick. I'll teach you this next week, but if you want to follow it for a sec, doesn't hurt to practice. 1 copper on this side, 1 copper on this side. That looks good. 1 silver on this side, 1 silver on this side. That looks good. 1 NO3 on this side, 2 NO3s on that side. So I got to put a 2 out front here. Well, that changed my silver. Now I've got 2 silvers. I put a 2 out front here. Now I'm balanced. 1 copper, 1 copper. 2 silver, 2 silver. 2 NO3s, nitrates, 2 nitrates. Perfect. He's perfectly balanced and he's written all the right way. You don't have to balance on today's sheet, but eventually next sheet or I guess by Friday, you'll be putting this all together, so you might as well just see me do it. Okay, that was one question. I'm going to now do question 8. I'll write it out for you. Lithium hydroxide plus hydrogen acetate yields lithium acetate plus water. All right, that's a long one. Can you see it? Okay. So, I'm going to have space up here to write my pretty formula and just some scrap space down here. Lithium hydroxide. That seems scary. I don't know what that is. Well, lithium is easy. It's on the periodic table. Let's go find it right here. Lithium. We're going to use the ion side because it's hooked up in a compound, so we know lithium had a charge. Lithium, you see it right here? It's number 3. It's a +1. So Li plus 1. And hydroxide. Well, you've never heard of that as an element because it's one of these polyatomic ions from the sheet. See it right here? Hydroxide, OH minus 1. If you crisscross, you get LiOH. They were 1 to 1, pretty simple. Lithium hydroxide, LiOH. Perfect. Plus hydrogen acetate. All right? I don't know what to do. Let's see what that is. Well, hydrogen, we know from the table of ions, hydrogen is a +1. What's acetate? Well, again, I'm going to get my polyatomic sheet and I'm going to see it right here. Acetate, C2H3O2. C2H3O2, and it had a -1 charge. Crisscross, I get HC2H3O2. I do not add this H in here. I don't say it's C2H4O2. I leave the polyatomics together. I don't break them up unless I have to, and this hydrogen attached to that. So you leave that together. So hydrogen acetate is just HC2H3O2. That's what that looks like, hydrogen acetate. So it yielded lithium acetate. Well, what does that look like? We've already got all our charge. This is written out here. So you can see lithium was a +1. Acetate was C2H3O2. -1. You crisscross, I get LiC2H3O2. Lithium acetate. So I better write that down. C2H3O2 plus water. Well, you guys all know water is H2O. But I prefer to write water HOH. Why? Because that OH is the same. This is the hydroxide. This also could be called hydrogen hydroxide. That's water. Sorry. Hydrogen hydroxide. Okay? Because when you look at this, HOH is how I prefer to write water. It's easier when we go to balance these things, okay? So when you look, you see a lithium got used, a lithium got used. OH, which is hydroxide, got used, the OH got used. Hydrogen is on this side, there's a hydrogen on this side alone. This acetate got used, this acetate got used. So everybody got used. This is a double replacement reaction, and we'll learn about that. It's already all balanced. Everybody was 1 to 1 to 1, so it's very easy that way. Okay? So you write water HOH. It'll make things simpler as we go forward. So this was number 8 on that sheet. Get some new paper. And I'm going to try, the last one I'm going to do is, I don't know. I'm trying to find right here, number 13. I'll find one that's molecular. Sulfur plus fluorine yields sulfur plus fluorine yields sulfur hexafluoride. All right, let's check out this one. I don't really need a scrap for this. We're going to talk this all the way out. So sulfur, that's easy. It's an element. It's by itself. It doesn't have a charge. What's its symbol? sulfur, S. S plus. Fluorine, again, it's an element, it's by itself, it doesn't have a charge. Fluorine, F. S plus F yields sulfur hexafluoride. Well, this hexafluoride, you guys learned how to do that on page 269. You saw these mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. These prefixes, we have to use those. So this is hexa. So hexa is 6. So that's on page 269 if you need to reference it. Oh, red pen, sorry. Hexa is 6. So sulfur hexafluoride. I say sulfur, that's easy. Hexafluoride, well, I write fluoride, and there's 6 of them. So that's sulfur hexafluoride. So we didn't have to do the crisscrosses. Why? Because this is molecular, which we use prefixes. These prefixes with hexa, hepta, mono, octo, all those. Okay? And how do I know it's molecular? Straight up easy. They're 2 nonmetals. Both of the elements are here to the left. Look, sulfur and fluorine. Sulfur and fluorine. Right here. So 2 nonmetals. They make it molecular, which means I use the prefixes, sulfur hexafluoride, and we're done. All right? So you'll see these on this worksheet. It really does practice your naming, going back and forth on the charges, okay? And it practices all of that stuff. So you'll be able to ask me questions in class. Classes are always Tuesdays at 1, so you can ask me questions, get brave, say I don't understand, how come there's no charges floating around, or whatever you need to ask me to clarify all this. Practice your question. You do have an attached answer key, so you should be able to do that. Next week we will be balancing, so let's just balance this one really quick. There's 1 sulfur, 1 sulfur. 1 fluorine, 6 fluorine. So all we're going to do is write a 6 here. This guy would be balanced. We'll teach you that a little bit later in the week. Okay, that's it for now. Bye-bye.